Hello and welcome to Func Prog Sweden. We are finally back after our summer vacation, so warm welcome. Func Prog Sweden is the meetup where we explore functional programming, as you might understand from the title of the meetup and stream. Welcome to all recurring members, guests, and subscribers of the channel, and also warm welcome to everyone that's new in Func Prog Sweden, watching this for the first time. Let's head over to today's agenda. On the agenda of today, we will have first a presentation by, not any presentation, but a short introduction by me. I will talk about some fun stuff and some other stuff. First presentation is Rust versus F# by Johan Olsson. That I know a lot of people want to see. And then we will also have Turn Old into New, moving to Elixir feature by Anita Ludermann. Also very interesting. I know that this presentation is good. And then in the end, if you have more questions you want to ask or more things you want to wonder about, head over to Discord and join the post-show chat. But before we get started, I would like to first thank Adabeat for sponsoring this video stream and this meetup. If you want to know more about Adabeat, head over to their webpage, adabeat.com, or check them out in social media. Then Func Prog Conf 2025, October 15th, we will run a half-day in-person event in Stockholm with 3 great presentations in functional programming. So if you want to come and check out and hang out with other people in Stockholm in October, when it's bad weather outside, come inside, join the half-day meetup or like half-day conference instead in October. Then if we look at the schedule for the coming fall, then next meetup, 23rd of September. We planned for that. We're going to announce it on meetup page also. Then 15th of October, we'll run the Func Prog Conf. Then 11th of November, we will be at Kivra. That's already in the meetup page. So if you want to join the in-person event on the 11th of November, make sure to head over to meetup and join already now. And of course, if you want to support Func Prog Sweden, join the group, meetup group, and make sure to subscribe on our YouTube channel. And also make sure to join the Discord to ask more elaborate questions. Which brings us over to questions. So if you have any questions during the presentation, please shoot them in the YouTube chat or in the Discord server. In the Discord server, you can ask longer questions. The YouTube chat is unfortunately a bit limited in size. So with that, let's get started and warm welcome Johan Olsson to Func Prog Sweden. Hello Johan and
Thank you.
welcome.
Hello.
Hello.
Thank you for having me.
Yes, you're warm welcome, and I know you've been working, you're a long timer within software development. You probably started working with software maybe around the time I was born.
Yeah. Maybe.
Yeah.
I started, my first job was in 1990, I
Oh,
think.
yeah.
But I started coding way before that, like in 83 or something like that.
Yeah. Yes, so warm welcome, Johan, and let's kick off your presentation.
Yes. Okay. All right. You can see my screen, I hope.
Yes. Yeah, we do, Johan.
All right. Rust versus F#, or the borrow checker meets the pattern matcher, or memory safety versus functional magic. What differs, what are equal? We're gonna take a look at what, no, it seems like it's the same show. Let's share that one. All right. This is all right. You see my screen now, a crab and a wizard?
Yes, we do.
Yeah. F# versus Rust. Who will win? We're going to take a look at what Rust is. We're going to take a little look at what F# is. We're going to compare what those two languages, what are the similarities, differences, strengths, weaknesses. We're also going to have a short discussion on when would you choose one over the other. And my name is Johan Olsson. I'm a consultant at TheTribe in Malmö, Sweden. A small consultant firm. We are about 12 people now, I think. And I'm currently working at Schneider Electric in Lund, where I do Rust programming, a bit of Golang, and a bit of .NET as well. And I have always had a passion for functional programming. And I have been a professional software engineer for 35 years now. And as I said, started coding back in the dark ages, the early 80s. And first, a disclaimer. I am not a Rust expert. This presentation is based on my experience as a F# programmer learning to write Rust. So it's my opinions and my experience. And I might get Rust wrong in some places. So just so you know. What is Rust? Well, Rust was released in 2012. It's built on C++, Cyclone, Haskell, and OCaml. C++, I think you know. That's very, very common. Cyclone is a C dialect with stronger memory checking. Haskell, a pure functional language. And OCaml is a multi-purpose language. Rust is strong typed. And it uses a memory model where you have ownership of memory. And you can borrow memory from other places. And you also have lifetimes defining how long memory should live and so on. We will look into that as well. Rust says we have fearless concurrency, and that is supported by the memory management model. Rust compiles to machine code, it's cross-platform, it's high performance. It's mostly used for system programming, and it's imperative functional language. If we look at F#, that was created in 2005. It's built directly on OCaml. It is also strong typed, but it uses a garbage collector for memory management. And there's a big difference. It compiles to and runs on the .NET runtime, which means it has the .NET garbage collector, and it also uses the .NET threading and ASIC await system. F# is a functional first multi-paradigm language, meaning that we prefer to write functional code in F#, but you could write object-oriented as well if you like. Typical use cases for Rust is low-level system, embedded systems, performance-critical apps. And for F#, it's more data science, finance, web apps, domain modeling, big data, stuff like that. And this might seem to be two very different use cases. And they are. But there are some commonality, there are common ground around these languages, is that they are both strong static type systems, and they both have functional programming support. They both have a very strong concurrency and safety model. They're cross-platform, and both emphasis on correctness. That means that if it compiles, it works. The compiler won't let you do the stupid stuff. And that is something I have experienced compared to object-oriented languages or other languages. There's a whole category of bugs that just disappear when you use a language like Rust or F# because you can't do it wrong. The compiler forces you to handle all cases and stuff like that. If we take a look at the basic syntax, Rust uses curly braces to mark start and end of a block, just like C++. And it uses a semicolon to end a statement, also C++. And type declarations are required in your functions. Whereas in F#, we use indentation to mark start and end of a block, just like Python. We use new line to mark end of statement, and type declarations are optional. You don't need that if there is no ambiguity. If the compiler can find out what it is, then you don't have to have type declarations. Common for both languages is that the last statement in a function is the return value, always. Here's an example of Rust. Here we declare a function add. It takes two parameters, x and y. Both are 32-bit integers. The function also returns a 32-bit integer and just adds those two values together. And there is no return keyword here. The last statement is the return value, and there is only one statement in this function. Then in the main function, we call this add with two parameters, 5 and 6. We get the result, and then we print it on the screen. This is a very simple Rust, but you see the curly braces, we have semicolons. It looks C++-ish. If we do the same in F#, we declare a function add that takes two parameters, x and y, and just adds them together. Notice here that we don't have type annotations. We don't say that x and y are integers because the compiler can figure that out for us. This does not mean that F# is dynamically typed. It's not. But in this case, as in the main function, I call add with 5 and 6, which are integer constants. That means add function must have integer parameters. Otherwise, this would not compile. So the compiler says, okay, you're calling it with int, then it must be int. It cannot be anything else. And here's the exact same thing. We add the 5 and 6, and then we print it to the screen. This entry point, that's the .NET runtime saying that you must declare a function to start the program. And we must also always return an exit code, an integer. So 0 on the last line is the exit code of this program. Right? Both languages have immutable by default. So you declare a variable and you cannot change it. You have to explicitly mark the variable as mutable if you want to change it. The compiler will tell you if you try to change something that you cannot do. An example of this is like in Rust, we can declare x as 5. We can print it. And then we try to set x to 6. We will get a compiler error saying you cannot assign twice to immutable variable x. So you can't do that. So what if you want to do that? Well, then you have to declare x as mute, as mutable. This means that now you can change it and the compiler error goes away. We can do the same in F#. We declared the variable x, set it to 5, and then we change it to 6. And here we will get a warning because this is not an assignment. X equals 6 is not an assignment in F#. It's an equality check. We are doing here, is x equal to 6? It's not, it's 5. So this will result in false, and we are not using that result. So the compiler says, yes, you can compare x with 6. It's pointless because you're not handling the result of that comparison. Shouldn't you do that? So F# compiler is a bit more forgiving, perhaps. If you want to do this in F#, you will have to declare the variable as mutable, and then you will have to use the special syntax of a left arrow that's saying, yes, I am aware I am putting 6 into x. I'm really changing that, because if you just say equals, that's a comparison, not an assignment in F#. Right? Memory management. In Rust, each value has one owner, one and only one owner. And when the owner goes out of scope, then that value is removed. In F#, we're using the .NET memory model. That is, we have a garbage collector. So when a value goes out of scope, nothing happens. The garbage collector will find that this value is not used anymore and remove it sometime in the future. We don't know when, but it will do it sometime. If we have a value that implements the iDisposable interface, then we can explicitly declare a scope, and when that scope goes out, then that value will be disposed, that is, removed. I will show how that works. But first, Rust, memory ownership. Here we first declare a string, S1. It's a string allocated on the heap. S1 is the owner of this string. And then we set S2 equals to S1. That means we're transferring ownership of this string to S2. S2 is now the owner of the data. If we try to use it, S1, we will get a compiler error saying that the borrow of move value is the ownership is S2. S1 does not have ownership of this anymore and cannot use it. So what we have to do is use borrowing. Here we create the S1, the string hello, and then we want to calculate the length of that string. Then we can say that function length can borrow my string S1 by adding the ampersand. That means you can borrow my string, but you cannot change it. It's read only. It's mutable, immutable. The calculate length function can do what it's doing with strings. It gets the length of it and returns that. And then we print what we got from the calculate length. So S1 is still owned by S1, and it's temporarily blended out to the calculate length function that borrows that string. And returns the when it returns, the borrowing is ended. And this is enforced by the compiler, so it's not in the runtime, it's a compiler check. Another thing is that we can transfer ownership to someone else. Let's say we have this data, that is a vector of 3 numbers, and we want to transfer ownership into another thread. Here I'm starting a new thread, and data is transferred, moved into that thread. So that thread takes ownership of that data. If I want to access data after this, the compiler won't let me because I have moved the ownership to someone else, to the other thread. And there's also another thing called boxing. You can box things, that is, you can allocate memory on the heap with something in. Yes, I allocate a box with an integer inside. And if I want to access the value of that box in the last line here, I have to use the star as give me the value of that variable. Here we see the C++ thing going shining. We have stars before that. We have also here the ampersand. So it's references, it's pointers, but the compiler enforces this for us, so we shouldn't be able to make mistakes. Right? If we look at F#, there's not much to say about the memory itself. The garbage collector will get it when we it's laying around, not used anymore. But we have this scope that if the data we have implements dispose, and we want to use that, then we can declare a scope by having the use keyword. For example, here we create a text file, and a text file implements dispose. And once we are done with writing data to this text file, we exit this function. That means the scope ends, the file will be disposed, it's closed and removed from memory. And that could be good because we don't want to keep files open, lying around. Well, don't know when it will be closed. We want it to be closed when we exit this function. So we could call file dispose directly in the code, but it's better to use because if an exception handle happens or some other errors, the file will be closed anyway. Right. Data types. Rust declares mainly 2 data types, enums and structs. In F#, we have discriminated union and record, but they are the same thing. They're same, different name. They are exactly the same thing. In Rust, we can declare a struct, a rectangle with width and height here. We can add functions to that rectangle, and here's an area function that calculates the area of that rectangle. We can use that rectangle. Here you declare a rectangle with 30, height 50, and then we call rect.area to get the area of that rectangle. And we can do the exact same thing in the show. We declare a rectangle with width and height. We add a area method that calculates the area, and we use it same way. Declare a variable rect width 5 and 10 here, and we call rect.area to call that function. Same thing. In enum, Rust has an enum type, and that is a type that can have a limited number of values. In this case, we have version 4 and version 6 of IP addresses. Those are the only two values that can exist. But what you also can do in Rust is that you can attach values to your enum. In this case, we have version 4 that has 4 8-bit unsigned values attached to it. And then in V6, we have a string attached to it. We can have different values attached depending on what version we are using here. So if we want to use a version 4 address, we can attach the values 127.0.0.1. And if we use a version 6, we attach a string. And this is very powerful. In F#, we can do the exact same thing. We declare a type which has two different values, version 4 and version 6, and we attach values to those. And we use it the same way. Version 4, 127.0.0.1, or version 6, ::1, a string. Now, this leads us to missing values. How is that happening? Well, in Rust, null does not exist. We use an option enum instead. In F#, well, null exists because we are running on the .NET ecosystem, the .NET runtime, and null exists there. But as F# programmers, we really prefer to use the option value instead. But we need to handle nulls sometimes. So what is the option enum? Well, it's an enum that has two values, some and none. So we can use it like this. We declare a value of type option int32 and set it to sum 42. So this value has the value sum 42, and no value has the value none. And then we have to match, and it's an advanced form of if statement, really. If the value is sum, then we can print it. If the value is none, well, then we don't have a value to print. We print no value instead. And when we do a match, the compiler enforces us to cover all cases. So we can't miss a case here. The compiler forces us to always use that. And we can do the exact same thing in F#. We declare a value of int option. Option is a keyword in F#, but it is the same thing. It's implemented as the enum in Rust, two values, sum and none. Works exactly the same way. We can match on that. If it's sum, we can print that. If it's none, we don't have anything to print. So exactly the same thing. That brings us to pattern matching. Both languages have strong pattern matching capabilities, and you can match them a lot of different things, values, ranges, data structures, etc. And both languages use exhaustive matching. That means that the compiler will complain if you do not cover all cases. F# also has an active pattern feature that Rust is missing, as far as I know. I will show that. So in Rust, we can compare or match on a range. We have a value 5, and we can match if it's 2 or less, if it's between 3 and 10, or if it's 11 or bigger. That's very powerful. A lot of variants you can do on this. And we can do the exact same thing in F#. Looks almost identical. Small details in syntax, but looks exactly the same way. In Rust, we can match on a struct. Say we have the variable rect. It's a rectangle, and we can match on if the width is greater than height, then we have a wide rectangle. If width is less than height, we have a tall rectangle. If they are equal, then we have a square. And then the compiler enforces us to have the other case, the catch-all case, that we don't know neither of these ifs fall out. So we have to do a third or fourth case where none of this is true, which should never happen really, but we have to do it. And we can do the exact same thing in F#. We match on the rect. We have its width and height. And we use when here instead of if, but it's the same thing. Width larger than height, we have a wide rectangle. If width is less than height, then it's a tall. If they're equal, then it's a square. And we also have to do the fourth case when none is true and say we don't know what this is. So record it can match a lot of things. It's quite powerful, actually. In F# we have something called active pattern. You can declare a function that can return different values. And that means that when I call match here, then that function will be called, and the result of that function is what will decide which branch of the matching expression we execute. Here we have even or odd, so that is called from the match, and the result is, let's say it's even, then that even will match, and we print X is even. This is very powerful because you can have very complex matching used in this function. You can have return variables and a lot of things, really. I haven't found any way to do that in Rust, actually. There might be. Another thing is error handling. In Rust, there are no exceptions. There is one unrecoverable error, kind of an exception, that is panic. If that happens, we crash. We can't recover from this error. We are going to say we're going to read a file and do some computation on the data in that file, and we can't even find the file, and it's pointless to continue. Then we panic and crash. Instead of exceptions, Rust uses results everywhere. That is, every function returns a result indicating if it was a success or a failure. We will look into that. In F#, there are exceptions because .NET has exceptions. We have to try catch or try web, as it keywords are in F#. And if we don't catch an exception, it will crash. But as F# developers, we like to use result instead as well. In Rust, a result is an enum with two values, OK and O. So, like if we try to open a file, that will give us a result back. and we have to match that result with, was it okay? Well, then we got the file and we can do what we want to do with that file. Or it was an error. It could be file not found, or maybe access denied, or something. We couldn't open the file. There was an error. Then we have to handle that. So if we want to read data from a file, we have a function here that read data from file. It will return a result string, that is the data we want to read from the file, or an IO error. We couldn't read the file, there's an error. So the first thing we do is we open the file, then we check, was it okay or error? If it was error, we return here, return that error. There's no point in continuing. If we couldn't even open the file, then we can't read it. So return if there's an error. And then we declare a string content, saying that here's the variable I want to use to have my content. And I'll do file read and tell it, put the content on the file into my variable content here. And if that went okay, it might fail to read. We have to handle that. If it was okay, well, then we have content. If something went wrong when we tried to read a file, we return an error. And there's underscores on some of the text here. My editor was kind enough to underscore everything that's mutable. So you could see that mutable variables here are underscored. This is a very common pattern that you do something, get a result back, you check, was it okay or error? If it was an error, then we exit. And then we do another thing, check it was okay or error, and so on and so on. So a very common pattern to do this. Do something, check was it okay or error. Do the next thing, was it okay or error. It gets a bit tedious, perhaps. So in Rust, you can do a shortcut. Here we have the file open, and then we have a question mark at the end. That means if this the result from this call was error, then we will return immediately. If it was okay, then it will continue. So if file open returns okay, and we got the file, and we can declare our content. We can read the file with with a question mark at the end, meaning that if it fails, it will return that error. So if we get to the last line, okay, content, then everything worked. So we have our content and we can return that. So that's a nice feature in Rust. You can do shortcutting like this. And you can even chain that. So here we open the file, have a question mark. If it fails there, it will return there. Otherwise, it will continue. Read to string, question mark. Did it work? Yes. Then we can return the content. If not, it will return the error. So that's a nice way to shortcut the matching of OK error. Right? In F#, we need to handle exceptions. So a file open here could throw an exception, and the exception could be file not found or access denied or something else. We need to handle that. So we try, open the file, and if something failed, well, we print them and the error message, and we throw or erase the exception again to someone else to handle that. But what we really want to do is use the result here as well. So here we have the read data file. We take a file name And this function will return a result of string, that is the content of my file I want to read. And the second string is the error message. So here I open my file, I read the content, and then I return it. Everything went okay, and here's the content. And if there's an exception, I return error and a message. So we've wrapped this error handling, the exception handling in a result function. So that's the way, at least the way I like to do it. There are other ways to do it, but I like to do it like this. So we can now have a result instead. I read the data from file, I will get the result back, and I have to match on that one. Was it okay? Then I can print it. If it was an error, then I have to handle that error. In F#, there are a way to shortcut this as well. What you do is that you declare a result computational expression, is the term, but it result block, really. And here we have let and an exclamation mark. So let bang, we call it. That means if read data from file returned okay, then content will be set. If not, we will return immediately from this function. So in Rust, we set a question mark at the end of a statement. In F#, we set an exclamation mark at the beginning. But it works the same way. It shortcuts. If it fails, then it will return. If not, it will continue this function. Another thing is higher order functions. A higher order function is a function that takes another function as a parameter or returns a function as the result, or both. In Rust, we can declare lambdas. That's really easy. We can have a function that has a parameter as a function. We can do that as well. It's a bit clunky syntax, I think, but it's quite doable, no problem at all. But when you come to having a function as a return value, it's possible, but it gets really complex because of the memory ownership and memory management. We'll look into that in a while. In F#, everything is easy regarding that. Declaring lambdas, no problem. Parameters, no problem. Function as return values, no problems. We don't have that memory management we need to handle. The garbage collector will take care of it when we're done. So in Rust, we can declare lambdas. Let's say we have a vector of 5 numbers. We want to iterate over that vector. And for each number, we call map. That is, we call this lambda, that is x as a parameter, and it returns x times 2. It multiplies by 2. And then we have a filter. We only want values that are greater than 5. And finally, for each result, we print it. And here's a quirk in Rust. The larger than operator, less than also takes a reference as the second parameter. I don't know why, but that's the way it is. So the filter x larger than has to be a reference to something. So it has to be a reference to 5, which is a constant. And that's a bit surprising, but that's the way it is. And we can do the same thing in F#. We have this array of 5 numbers. We call a lambda that multiplies it by 2. We filter then with a lambda that filters out everything that's bigger than 5. And finally, for each value, we print it. Same way, same thing. Syntax is a little bit different, but it evaluates to the same thing. If we want to have a function as a parameter, we can do that in Rust. Here we have binary operator function that takes 3 parameters, takes n and m and an op. And op is a function that itself takes 2 integers as parameters and returns an integer. So here we need to declare binary operator as a template function and have the type of the parameter as a where. It works. It's a bit clunky, I think, but there's no problem with it. So we can call binary operator 2 values and the function that we want this to execute. So first we do it with add, and then I do it with multiply. Given that add is a function that takes 2 parameters, takes 2 integers and returns 1, multiply the same. So it's doable in Rust. A bit clunky, but works fine. If we want to do that in F#, that's it. We just declare that binary operator takes 3 parameters, and the result is op and x and y. That is call op with x and y as parameters. That's it. Not much more to add about that. If we want to return a function, then it gets a bit complex, because we have to take into consideration who is owning the parameters to the function that we are going to call. So you have to add something, this tick A, which is a lifetime that tells the compiler that these values all belong to the same lifetime. So when this value goes out of scope, all these values should be removed. I'm not going to go too deep into this, but it gets hairy quickly. But basically, we call unapplied binary operator with 3 values, 2 constants, and a function that we want to execute. And we get the function back that we can execute at a later time. And that is what gets it a bit hairy. Who is owning the data that we have during this time? And then finally, we call that function and we get the result. So it's doable, but not easy. In F#, well, it's just easy. We return a function that do this, and we're done. So in that case, F# is much easier to do, just because we don't have to take care of the memory. Who is owning the parameters? Who is owning what? We don't care. The garbage collector will fine do it for us. Another thing is partial application and pipelining. Both languages support partial application and pipelining as well. F# supports it by default. In Rust, you have to add an external package to this. So partial applications, you can say that add5 is a function that takes 1 parameter, x, and what it does, it adds x and 5. Double it is a function that takes 1 parameter, it multiplies x with 2, and print it. Yeah, it prints the value. Then you can declare a pipe or a pipeline that starts with an 8, then calls add5 on that one. The result of that will be used when calling double it, and the result of that will be used when calling print it. So we take 8, add 5, double it, print it. Nice little pipeline that's easy to read and easy to understand what actually happens. We can do the exact same thing in F#. We declare add 5, the double it, and the print it functions. Then we declare our pipeline, start with 8, add 5, double it, and print it. Exact same thing. If we look at async, in Rust, we declare functions as async, and then we call await to get the result. In F#, we wrap it in an async block, not an async computational expression. And then we use let bang, do bang, and return bang to await the results. In Rust, it looks like this. We declare async function. We do stuff. Here I call sleep for 1 second and do await on that. So we wait for 1 second and then we calculate the result. And now we can call do stuff in my function here, something, and then we await the result. So it will take a second before that result is done, and then we print it. Quite easy to use. In F#, we do a little bit different. We declare an async block or an async computational expression. Here we do, because async sleep does not return anything. We don't have anything to check against or handle the results. It's just do this. There's no return value. And as we do exclamation mark inside an async block means await the result. We sleep for a second and return the result. And in something we do an async block, we use let exclamation mark, that is await the result of do stuff 42, takes a second, and then we can print it. So we can do async in F# as well. It's a little bit different, but mainly more or less the same thing. So what we have seen is that both languages has similar syntax and features. What differs is the memory management. That's the big thing. If we look at tooling, both languages have strong support in VS Code and other editors as well. Rust, I would say, has a steeper learning curve due to the memory management. That takes a while to wrap your head around. And thus, F# is a bit easier to learn, especially if you're familiar with functional programming. Rust has a growing ecosystem and packages. Rust is becoming more and more popular now. F# has a huge existing ecosystem. I mean, .NET has been around for, 23 years now. There are packages for everything. So it's a huge ecosystem. Rust has a growing, vibrant community. F# community is smaller, I would say, but very passionate. So when would you choose one over the other? Well, if you have a use case that is tight memory, very performance critical IoT device or a smaller computer or whatnot, Rust. Definitely choose Rust. That's what Rust was meant to do. So that's what you should do. On the other hand, if you have big data, a lot of complex data structures and data analysis, F#. because that's what F# was meant to do. But life is never this black and white cases. There's always a gray scale. So when do you switch from Rust to F# when you move along this gray scale from small devices to big data? I don't know. It's more or less up to you, really, or your team, your current infrastructure. If you already have .NET runtime in your system, then maybe F# is better choice than Rust, and the other way around. If you don't have .NET runtime, then maybe bringing the .NET into your system might be a big step. Might be better to use Rust instead. But it depends. And I would say it's up to you. You have seen they are quite alike in their syntax and features and how you write things. It comes up to the ecosystem you want to have, really. In my case, I would probably choose F# over Rust more often than the other way around, mainly because I am comfortable with F#. I've written a lot more F# code than Rust now, and I just prefer F#. That's my thing. So that's it. Thank you for listening. And if you have any question, just let me know.
Thank you very much, Johan. Thank you for your presentation. We have a question immediately in the chat. I
Yep.
assume to you, Johan, I assume you have done quite a bit of coding in C# also. Do you have some personal experience regarding any benefits switching from C# to F#?
Yes, as I mentioned, quite a lot of, or a whole category of bugs just disappears when you do functional, when you go F#. All those cases where you missed to handle a case, you can't do that because the compiler won't let you. So runtime errors almost never happens when you do F#. So yes, I would say it might take a little longer to write the program, but if it compiles, it works.
Yeah,
that's my experience.
Agreed. Another question for me, it's maybe not C F# versus Rust, but more, you mentioned Rust being smaller. I mean, I seen comparison on the internet, I don't know, but still is C, I mean the old programming language C is still relevant for really small devices? Or when you're super memory constrained?
Yeah, it is, but I think Rust is growing in that department as well, because it can be very, very memory tight, and you have very good control of the memory when you're using Rust, and you get the compiler helps you a lot. Yep. So it's very, very difficult to shoot yourself in the foot, which you can easily do in C.
Yes. Anyone coded in C knows that it's it's very easy. People are just thanking you in the chat for your very nice presentation. So thank you very much, Johan, and for your nice presentation. F# versus
thank you
Rust.
For having me.
Yeah. Okay. Then thanks you very much, Johan, for your presentation. And now we will head over to our next presenter of the evening. Welcome to us, Anita. Hi, Anita.
Hello.
Hello, and warm welcome to Func Prog Sweden. You're coming with us from Aachen, I assume it's pronounced.
Yeah.
Yep.
Yeah, exactly. I'm from west, most western part of Germany, like nearly the Netherlands.
Oh, okay.
And yeah, thank you for having me.
Yeah. Warm welcome, Anita, and kick it away with your presentation.
Yeah.
Yeah.
Looks like it's perfect. Yeah, then hello.
Hello.
Yeah, as I've said, I'm Anita. I want to share with you and talk that I've already held at the conference in May at the Elixir Conf in EU. And I want to talk to you about how we at my company started moving to Elixir and what obstacles we met and how to do this, without breaking everything. So we've already established Amanita. I work at Model Aachen, which is a company in Aachen, which is also where I live. Another part I'm really proud of is I'm co-founder of the Ladybugs, which is a meetup for women in software engineering. So kind of a passion project. Yeah, that's it about me. So for my agenda, first I want to introduce you to Model Aachen, like tell you what we do and how we do it, so you understand what I'm talking about. Then I want to talk about the definition of legacy code, show you how we got started with Elixir, which is called a walking skeleton or building a walking skeleton. Then talk about our approach to moving legacy code to Elixir. So the example of a string logic pattern. And then I want to show you where we are now and our takeaways from our move so far. So first of all, who is Model Aachen? Here you can see my colleagues, or some of my colleagues. Were quite a lot bigger by now. We started back in 2009. I did joined the company in 2021, and we work in quality management basically. So we have a software that our customers buy and can use, and we also offer consulting services because just introducing the software without also doing some consulting doesn't change the approach in companies. So the consulting part is still pretty important. Currently we are 50 plus employees. We are in a growth phase, so it's all from the business perspective. It's also interesting to see how it's going. It's excited currently. So our software, which is what we're here to talk about. As I've said, we work in quality management. It's an interactive management system. So our goal is that everybody can change processes or can propose to change processes. So we get the documentation as close as possible to the real world. And we also have functions or features for auditing. So like if you have ISOs, you have to confirm this or something. That's something we do as well. Our main focus is software as a service. So we have cloud first, but we also have some on-premise clients, and they're probably not going away. Or it's a slower moving part. So we also have to keep that in mind as well. And so how do we work in our developer team? We basically, you can say we work with incremental steps all the way. So we do test-driven development, which means we are confident if we do changes, if we change stuff, that we don't break everything. Sometimes, of course, unexpected stuff happens, but that's also one of the main reasons for the later parts. We do CI/CD. So if we need like 30 minutes from code to client, at least to SaaS client. So if we break stuff, we can also fix stuff quite quickly. Then we work with domain-driven design. So we shape in contexts. And we work agile. The framework we use is called ShapeUp. The main thing you need to know for now is that we release to enterprise like every 2 months. And even if we deploy stuff to our customers without them knowing, like with feature toggles, we also remove them mainly every 2 months. So that's the main part. If you want to talk about ShapeUp, write me a message because I'm very passionate about that one too. But yeah, the main thing you have to know, incremental steps all the way. So this sounds fine. So why do we even want to move? Why do we want to change stuff? And what does old mean when I say turn old into new? And why elixir? These are the want to show you why. So back when I joined our tech stack, and at the beginning of 2022, or at the end of 2022, before we started with Elixir, our front end was Vue, so JS mainly. Our backend ForceWiki and Perl, which is the old stuff, and our database is PostgreSQL, and still is. So the front end is okay, backend is okay, database is okay, but the backend in between is slowly crumbling because Perl is quite an old language and doesn't have to be a bad thing, but in our case, this means that the documentation is often outdated. So if you Google something for Perl, you land on Stack Overflow with a topic that has been closed like 13 years ago. And it's really hard to find newer stuff. The other thing is it's not actively maintained or not actively developed further, so it has missing technologies. So for example, Perl does not offer what they're called web stacks. So which were introduced, WebSockets, sorry, it doesn't offer WebSockets, which were introduced in 2011, and we needed them for a feature, but we couldn't get them. So that's not ideal. This is one part. Why does this happen? Well, languages, or in general, software ages, code ages. I mean, we mostly know this. What I think is interesting that you can see kind of loops, like UI is like every 3 to 5 years you have something new. Logic is every 5 to 10 years, so backend stuff basically, or the stuff between that. And the infrastructure, so databases and things like that, are like 10 to 20 years. In general, it's not always the case, but if you look at what happened in the front end or UI in the last years versus in databases, it's quite a big difference. Okay, so Perl ages, it's old, okay, but that's not our main problem. Our main problem actually is FOSS-Wiki. FOSS-Wiki is a framework or wiki software that's open source. It's made for on-premise, so it's a file-based storage system. It doesn't have a database. It uses Perl and JavaScript, and the main thing is it's highly customizable. So it has a custom markup language. It's customizable with plugins. And FOSS-Wiki is actually how KuWiki started, like how we started as a startup. It was a full startup mentality, like make it happen, ship it to the customer, learning by doing. And it was not so much software engineering expertise. Not because we didn't care, but because, well, we were mostly people fresh from university. So there was not a lot of expertise in the team. So we forked FOSS-Wiki, or my older colleagues forked FOSS-Wiki, and customized the hell out of it because we needed missing use cases. to, ship it to the customer to get more clients. And this all makes the perfect storm for legacy code, because this means that our software is not that controllable anymore. So basically, every time you go into the core post-wiki stuff, legacy stuff, you feel like this cat falling in a bathtub and think like, okay, where's the exit? How can I get out of here again, please? The old code is often spaghetti code. It has a low modularity. There's a lot of black magic happening. So if you change one line, you don't know what else is happening. There are very few, only few tests. And so this all means it's hard to read, harder to understand. If you wasn't there when it happened, you don't know what to do. And this all basically means we have no control. So we don't know if you change something in old code, if the feature will still work afterwards when we ship it to the customer. Because due to this high customization and also a lot of possible customizations the client could do themselves, we don't know what happens if our theory code meets reality. So that's where we were in the beginning of 2023, by the end of 2022. And so what now, or what then? Better. That's when we started with Elixir and started to think about how to clean up this big ball of mud, which is called in software engineering. So the first start is, well, often the first instinct is to say, well, let's just start from scratch, start from zero. But the problem is we still need the features, we still need the clients. We can't go into into the cellar and program away for 3 years and then come back and say, it's new now, it's better now, because customers won't wait that long. So the first thing is to appreciate your legacy. We built this, it made us who we are in a sense. So like it's the core of Model Aachen, and we still need the software to work. But it doesn't mean we can't change it and make it better. So the next thing, once you figured out that, okay, starting afresh isn't quite that possible with that large a project, is that you need a vision. So for us, that's meant domain-driven design. So we want to take our spaghetti code and cut it into contexts. So we have feature 1 in context D, we have feature 2 in context B, and basically have a feature from that, it's as modular as possible and as independent as possible from the other features. So this is when we started to think about, well, if we're gonna do all that stuff, can't we also improve our language, our software habitat, basically? And we decided that we wanted to move to Elixir. We made a comparison between Elixir and F#. So like we knew we wanted to go to a functional programming language. And we did some research, and in the end Elixir won just because the habitat felt nicer. Like you Google something for Elixir and you land on Elixir pages in a nice forum, everyone is cool, or everyone is nice. And with F#, it was often that we ended up on C# pages where you had to figure out if it's still applicable to F# or not. So that was one of our main reasons. And some of us had played around with Elixir and found it good. So, and also with F# and found Elixir better. So that's why we decided to go to Elixir. Currently our goal is to have move our backend elixir. So we want to the backend database. In the long run, maybe we want to use live view as well and go for the elixir frontend as well. But for now, we wanted to keep the scope smaller. Because, yeah, as we've said, we still need to keep building our features and deliver value to our customers, and doing everything at once is a bit difficult. So at the beginning of 2023, we had an opportunity. We, with our shaper method, we decided to work on a certain feature, and that was outdated, that already existed. It was outdated in ForceWiki and Perl. It was really core ForceWiki functionality, but it needed WebSockets. It didn't have WebSockets. And it needed to be redone. So also, it didn't need a lot of data. So we knew we just had to move the logic and really don't do much with the database, with the tables and with the schemas. So it was a good opportunity to try out to go to Elixir. We always estimate between 2 and 6 weeks to get features finished, and we were pretty sure that we could do this. Okay, let's take 2 weeks to try this way and see how far we come. And if it's not working, we can go back and do this one. But we can try. And that's what we did. So first, we wanted to build a walking skeleton. So the goal was to get Elixir into production, which means we have a vertical slice all the way through from the front end, talking to the Elixir backend, talking to the database and back, without anybody noticing that there's something additional happening. Since we work with Kubernetes, we had to do a lot of stuff with the infrastructure and added Elixir ports and stuff like that. But this talk is not about that part. It's more about the software part. But we can talk about that one too. So yeah, we wanted to build a skeleton without the user noticing. So what does this mean? What does the user notice? Well, it means seamless UI. So the user shouldn't feel a difference, maybe a bit faster, but nothing negative. We need extra good session handling, because the user is not supposed to have to log in again. So it's not like KubeWiki 2.0 where you have to log in again if you switch between the features. And data consistency. We can't afford to lose data. Like if the user is looking for his process and it's gone, that's not good. So these were our three, goals or benchmarks to reach for the skeleton work. And seamless UI, done. We're working in Vue. So as long as we only do Elixir in the backend, easy. Also, we already connected a Vue with a REST API with Perl, so we did the same for Elixir as well. Next part, seamless session. So we wanted to avoid the additional login, and with this meant we had to build up on the existing session store. This is in ForceWiki and in the database, basically, the whole way in Perl. And the authentication uses the existing ForceWiki session. Like we have a ForceWiki session that we built up, and we wanted to use that as well and use the cookie that's that's stored in the browser. And for authorization, we use role-based access control. So we had to make sure to make these roles available in Elixir as well. And our solution for that was to allow the communication between Perl and Elixir. So we wrote a custom session plug. I don't know if you've worked with plugs in Elixir, but if you did, or like in Phoenix. But if you did, you can override the default session plug with your customization version. And basically it meant that our front end sent the cookie to the elixir backend, and the session plug went over to Perl and was like, is this valid? And the Perl session store did what it did before, validated the cookie, loaded the roles and the tenant and the user ID, and gave it back. So that's the second part done. We have another part of our skeleton. It does sound a bit easier than it was. Like were tricky parts, definitely, especially moving everything to Elixir after a while, which we've done by now. But that's how we started. Next part, data consistency. So our data needs to be consistent. We have one database and then multi-tenancy. So every tenant has their own tables, so they don't use each other's data on accident. So we need schemas. And we needed to make the existing data tables available for usage in production as well as in testing. And as I've said, we work with CI/CD, so you always have to think about what you change and if it's backwards compatible or not. If you work with CI/CD, you know the pain of migration sometimes. Our solution, migrations. We already had migrations in Perl anyway, so we knew what we were doing because, of course, we have changed my schemas before. We use the hex or the library triplex for multi-tenancy, which is basically Ecto plus multi-tenancy. We use still our Postgres schemas, and we had to add provisioning and deprovisioning to Elixir. So if we create a new client, this has to work for Elixir as well. This was some of the more tricky work to get this into the right to make it in the right way. Because if you do Perl first, then skip, and then the Elixir, and then Perl again, was easy to mix up. In the end, we basically have migrations for live or for production and tenant migrations. So migrations are for the public schema, which is used for example for the event queue, and tenant migrations is for each tenant. And then we have test migrations, which just makes our life with CI easier because it means we can put migrations in there that don't run yet on production, which allows us to change things easier because we just have to migrate our local system back and forth and not everybody on the production. And then the big part, which also goes for Perl as well, but migrations need to be idempotent. So we will have to be able to run them again and again without them breaking stuff. And we always have to implement up and down. In Perl, there was no real down, at least not if you didn't do it on purpose. So this is something Elixir is, better at, basically. That's something we have to keep in mind. But with that, next part, we found an arm. That's the schema part. The other part is data, because our data needs to be idempotent as well, no matter from which page you come. Here's an example for, but it's we basically added a column that didn't exist beforehand and then filled it with the right data, but you don't have to understand it now. Data migrations also need to be idempotent, and they also have to be implemented for up and down. At this point in time, when in doubt, we write it in Perl. Like now, 2 months, 3 months further, we're starting to work on it. and how to run Perl Elixir migrations in the testing, the testing environment, but not in the production environment. But for now, it's if in doubt, write it in Perl. Our tooling is there, and especially back in 2023, it was write it in Perl. We know what we're doing there, but it works, and we could do the most important stuff. So another arm found. Well, then I want to show you a bit of under the hood. Like we have, okay, the user doesn't notice, but what's with us in the backend? How do we communicate between these contexts without ending up with this big ball of spaghetti code again, or with this big ball of coupling again? Like we want to avoid coupling and we want to have high modularity. Again, in domain-driven design, this is built in if you do it right, but we had to think about how to do it, especially with contexts now being some in Perl and some in Elixir, where you couldn't just make an exception. And also always making synchronous call from Perl to Elixir and back, or the other way around, takes a lot of time, and it's still a website, so our users still expect to, well, it not take too long. That's where events come in. I don't know if you know event sourcing. Basically, you work with events. So you say, context A says, I've done this, and context F looks for the event and then reacts to it if needed, or if they need it, which means you have eventually consistent data, but it's not synchronous. It's asynchronous, so you can be faster. This is this is what we had when we started with Elixir. Like we have service 1, which listens to an event handler. Event handler handles the events that are written into the database. Pretty easy. Now we have the service 2 and want to react to this event that service 1 creates. No, sorry, that's the wrong one. Want to add an event as well, where we did the ugly but quick version and just persisted it in the same database. Like ignore O-Bahn, ignore everything, just take the same queue, same existing tooling and put it into the database and wait for the event queue to work it. Not nice. By now we have O-Bahn, so, but yeah, that took a while. That's the part for the publishing. Now the other part that I started to talk about already, the event listener. Now we have service 3 that wants to listen to an event that happened here, that happens in Perl context. What do? We added a trigger in the event handler that if the event handler, like we add to, like if this is for Elixir basically, also trigger the listener over there. Which is the other part. Again, in the first place, not ugly, especially if you start with more features over on Elixir side, and especially core features on Elixir side, we started to play a lot of ping pong. So we got to the point where we said, well, we need OBARD now. We want to have our own Elixir event queue. This is again where we started. So if I've counted correctly, we have all the parts now. Like we have a torso, we have 2 arms, we have a head, we have 2 legs. So is it viable? Yes, it was viable. Like we managed to integrate Elixir as far as we could in 2 weeks. And then we were confident enough that we could finish the feature in the whole 6 weeks. And we did. UI was there, session handling was there, consistency was there, and the feature was there as well. as we said, feature was pretty small, so we did that in about, I think, 2 weeks or 1 week. It works. Is it pretty? No. Every time we now look at this feature code, we are like, what were we thinking? But it worked. We got it started. The time invest at that point was like 2.5 persons for 30 days, for a month. It was 2 software engineers, and the half person is one of our DevOps people who we had to, who was very involved in getting the Kubernetes cluster and everything to run. So yeah, success. It worked. And now, what if you have a feature that's not completely well doable in 2 weeks or in 6 weeks? Like what if it's bigger? How do we get this big ball of wool of mud over there? Where can we shape it? I want to show you an example. For us it's attachments. It's like the biggest example not anymore, but the biggest example, one of the biggest example we did. And that took us a long time, but in the end it worked. So attachments basically means you have a page where your process is written on, and this process can have an attachment where you say like, I don't know, fill out this PDF, or here's more information on this PowerPoint or something. So just an attachment as you would imagine in any other software. But we worked with the Strangler-Fig pattern for that. The main idea of the Strangler-Fig pattern is, I don't know if you know the Strangler-Fig in real life, but it's a plant that basically plants itself into a tree and then starts to grow on that tree using the resources of the tree. So first you have the old part, then your feature grows, your old feature dies. Like in the real life nature, the Strangler-Fig uses more and more resources that the tree would need. So it slowly dies, and in the end you only have the Strangler-Fig left. Not that nice, but very good in software engineering. So the first part, what did we have? We have a page with an attachment in our page. When it loads, goes to the attachment service and says, do I have attachment? Or I know I have an attachment with an ID, please give it to me. And then we save and load it from the metadata and also read and write from the file storage. So basically, when was it uploaded, who uploaded it, stuff like that. But also, load the actual file from the storage. The first thing we did, like the first part, was with another feature actually that was not for the full attachments, but for profile pictures. So if you're a user, you were supposed to be able to upload a picture of you. Because it's nice to have a picture of you in your profile. So basically we shaped this thing to only contain a new attachment service that had the minimal stuff that was needed for a profile picture, which was save and load the picture metadata, which was like the name of the user for whom the picture is, and the size. And then read and write the file of the picture to the file storage. That was our first step. Then, of course, we kept the profile pictures, but it's not important for the rest. We started reading the info. So we had the attachment service. We knew that reading and writing the metadata and the file worked on elixir part. So we extended that to work for all our MIME types. And then we added in the attachment service, we added a call a synchronous call to the attachment service on elixir part to say, give me the info. The saving we still did on the first. Then we added the writing as well to work over elixir. So by then we could remove with these parts, like the reading and the saving, like this connection from Perl to the database and to the file storage from our code, which was quite a lot of code we could delete. And then we started to reroute the front end so that we started to edit in the REST endpoint to also go over Elixir and ask Elixir for the attachment instead of the attachment service, which then meant we could remove the rest of the attachment service and one of the big features in FOSWiki. Because this was core FOSWiki, it was a lot pretty tricky to extract it and get it out of there and into Elixir without the user noticing anything. I think we took about three-quarter of a year, but there was a lot of other stuff going on. Like we also moved to S3 in this time, so it wasn't one straightforward way. Yeah, but that's it. This way we got rid for this feature of Perl, and that's what we aim to do with every other feature as well. So we always move bit by bit by bit and see how well we can move. So the main challenge of this is to find the smallest part you can move without breaking stuff. That's like the main challenge. But it's also fun if it works. So yeah. So where does it leave us? Where are we now? Well, if you look at our code 2 years later, we still have a lot of lines in Perl, but we also added continuously a lot of lines in Elixir. And you really have to say, every time we add a feature in Elixir, it's so much smaller, like code line wise, than in Perl. That's definitely one big thing. And also we're continually, we're not as fast as we thought we would be in the first place. But also, as I've already mentioned, we're growing quite a lot. We're focusing a lot of new features or making features better for our customers and shipping value. So it's not like reducing Perl is our main focus. It's more like a continuous thing we're doing. And there are always features like if you look at this part from here to there, this is where the attachments moved. And this is quite a big jump. And we're expecting to see more and more jumps of these when we tackle the big features that are still waiting. So our ongoing challenges are always this new features versus modernization that you always have in a company. Like, do we listen to sales? Do we listen to the developers? Where do we put our energy? And the other big thing is figuring out the functionality of legacy features. Like we have some features which work as the customer wants them, but if you ask people what they want, they don't really know. And we are not always 100% sure what all the functionality means, because since it was highly customizable, or is in some parts still highly customizable, you don't always know what the customer actually did with that feature. So sometimes we take away stuff and someone writes to our support like, I was using that. And then we always have to figure out how to, not lose customers over this. So again, find focus, write new features in Elixir, and move things whenever possible. So if we need 1 day extra to move this thing to Elixir, we will do it. If we need 3 days extra, we will probably do it. a bit depending on the time, but it's basically every time we can, we move. So where does it leave us? What can you take home from this? First of all, as I've started in the beginning, incremental steps all the way. This also goes for legacy code. Start small, figure out a guiding star, like where you want to go in the end, where you want to be. Like if you want to do domain-driven design, if you want to do event sourcing or things like that. These are big decisions. But once you know you want to go there, then go bit by bit. This is one of my favorite comics. It's yeah. For me, it encompasses the working with legacy code, like getting a bit part out of it and making it nice, making it workable. The other stuff is enable yourself, and also especially yourself as a software developer in your software team. Enable yourself to move fast, like to have good test coverage, at least for the feature you're working on right now. Go for early feedback so you can quickly gather feedback from your customers, of your clients, or just your internal customers. And yeah, look that you can how you can add value with small features, but also how you can add value by having a big feature start small. And there's always this discussion between business value and versus tech debt. I think this is one of the main things we need to accept as software developers. It's always the same discussion, but with the steps, and yeah, like if you can go fast as a software team, you can also lead this discussion and have a good balance between the two. And also every bit counts. Like everything you move to, that's more controllable now is a good thing. So every step, baby steps. I've also brought some recommended literature. So first of all, working effectively with legacy code is like a classic. Refactoring is also like a classic. And one of my favorite books because it goes a lot into how legacy actually happens in real life. Kill It With Fire by Marianne Bellotti. I can highly recommend it. It's very enjoyable to read. And yeah, that's it. Thank you so much. If you have any questions, now is the time. And you can find me off LinkedIn, on LinkedIn if you want. I think the link is also in the YouTube. But I will also in the Discord, so just ask me what you want. Thank you.
Thank you very much, Anita. Thank you very much. Love your presentation. I already got one question.
Thank you.
Yeah, I already got one question in the chat. You said that you knew that you wanted to use functional language even before choosing Elixir. What made you so sure about going functional?
Well, we started in Perl with object-oriented programming, and we, again and again figured out that we had problems with, I don't know the English word right now, sorry, like stuff happening that you didn't intend. And so we already went more to functional programming in Perl.
Mm.
So, and we were happy with that and noted that we had less, it was more controllable in the end, I think. It was easier to have modular. I really don't know the English word right now. I'm sorry. Nebenläufigkeit.
Yeah, I think that we understood and the audience understood also. Next question.
So,
yep. Next question. If you knew when you started, what
you change a class, some object. Sorry, can you repeat that?
Yeah, sure.
My video stopped.
Yeah, I'll shoot the next question. Would you have done anything differently today with the competence or with the knowledge you have today, doing the same journey?
Good question. I think we would have a more realistic approach to the time we need for all of this.
Mm.
Like we thought we would be maybe done by now, not really, but farther than we are.
Yeah, okay.
So in retrospect, we would have used other features, I think, but the main points still stand. Like the approach in itself is still sound.
Yeah. Okay. Another question. Did you like Perl?
It has some good parts,
Hmm?
but I prefer Elixir so much. Like Elixir for me is the easiest language I ever gotten into,
Hmm?
and I've met a few languages by now. Um, Perl is fine if you use it the right way, but it's so easy to overcomplicate it and like have a regex this small do what so much. This is on the one hand cool, and on the other hand so easy to get out of control.
Yeah, I agree with that. Yeah. Um, Next question. Your favorite feature in Elixir?
That we have now, or in the language Elixir in
That's a good
general.
question. We don't know. We just got a question, so go for what you have now then.
Well, in Elixir itself, it's definitely pattern matching.
Hmm?
Like I love having 5 of the same functions, having the business logic in the guard or something, or in the signature of the method. It's so nice to read afterwards. And for our favorite, or my favorite feature in our software,
Hmm?
I think it's still the attachments, because it was really a lot to do, and I did or participate in a lot of that.
Hmm?
And it was cool to make it nice and see how far we got.
Cool. If not Elixir, what other functional language would you have picked? Would you have gone for F sharp or maybe something completely?
Yeah, probably.
Okay, interesting. Um, what has been the advantages of using Elixir over Perl? I think you've answered that a bit, but maybe you can elaborate a bit more.
Yeah, yeah. The functional programming part is the one
Hmm?
thing. Like it's also easier to get into it. Like we have apprentices in our company, and they find Elixir so much easier than Perl to get started with, especially as a first language.
Yeah.
And then we also have, like the best example is we have one front end engineer. Like he started as a front end engineer and then went full stack because he liked Elixir.
Mm.
And I don't think that would have happened with Perl
No.
at all. So that's really cool.
Yeah.
And I also like the community part,
Mm.
definitely. Like in Perl, it's hard to find people to talk about this, and it's Elixir. It's at least online, it's easier.
Agree. Agree. It's a very engaging community around Elixir.
Yeah.
Were there any performance issues moving from Perl to Elixir, or any kind of performance related things?
Uh, our Perl, like it's FOSWiki, right? It's not
Mm.
the Perl part that's the problem. It's the FOSWiki part that's the
Mm.
problem. But it's so slow, or it was so slow already because there's so much build up that's getting loaded again and again that doesn't
Mm.
have to be loaded.
Mm.
That everything in Elixir feels way faster.
It's nice.
So we found some issues. Yeah, but it's only, yeah, the usual stuff. Like
Mm.
if you have a lot of calls, you run into issues.
Yeah. Cool. That I was think you've answered everyone's question. Again, thank you very much, Anita, for joining us and presenting. I think this is a really nice presentation, just showing that you can go from like deciding to swap out a legacy language to a newer functional language. So thank you
Yeah.
very much. Yeah. So
Yeah, thank you so much for having me.
yeah, thank you. And then thank you very much, everyone, for joining tonight for our 2 presentations. Now, in the end, we saw Anita's very nice presentation on how you can switch out an old Perl legacy code to a newer elixir-based code. And with that, I would like to thank everyone also watching and also very engaging in the chat. Thank you very much for that. I know that the presenters love your engaging talks or your engaging questions in the chat. So thank you very much. And with that, good morning, good afternoon, good evening, wherever you are. Bye for now.